Today's lesson is just a continuation of what we did in our previous lesson. If you remember, in our previous lesson, we discussed about how we can use the change of variable method to solve a first order linear partial differential equation with constant coefficient. And if you remember, we only did one example in our previous lesson. In today's lesson, we are going to do additional 2 examples in addition to what we did in our previous lesson. So in all, we'll be looking at what 3 examples. And by the time we are done with today's example, we should be able to solve a first order linear partial differential equation with constant coefficient using the change of variable approach. With our previous discussions that we did on change of variables, I gave you some steps that is going to help us solve a first order linear PDE with constant coefficient using the change of variables. So we are going to follow the same steps in solving this example that we are going to look at in today's lesson. So without wasting much time, let's set the goal. But before that, if you haven't yet subscribed to the channel, kindly hit on the subscribe button for me. So with today's question, it says that we should solve the IVP initial value problem, IVP, which is 3ux plus root 3uy is equal to 1 subjected to the initial condition ux0 is equal to s squared. So it means we have to find the general solution and then we find the particular solution using the auxiliary condition given. So in using the change of variable method as we did in our previous lesson, the first step is that identify the coefficient of what ux and then uy. We have the coefficient of ux, we have a is equal to what 3, and then the coefficient of uy is root 3, and that's what b is equal to what root of what 3. So once you get it, you find your angle or your alpha, and we know that our angle is given as tan alpha is equal to what b all over a. So from here you can say that our tan alpha is equal to our b is what root 3 all over what a. Our a is what 3. So from here we can see that our alpha, which is the angle, is equal to what? The tan inverse of what? Root 3 all over what? 3. Now when you punch it on your calculator, you are going to get your alpha to be 30 degrees. Or you can convert it to radians, that is pi over 6. So you can use the degree or you can also use the radians. So you are going to make use of degree. Now once you get your alpha, we write down the expression for xi and then the expression for what? Eta. That is the second step. So we write the expression for xi and then eta. So we know that our xi is given as what? X cos alpha plus y sin alpha. So this means that we should find cos alpha and then we should find what? Sin alpha. So from here we can see that our cos alpha, so we have cos alpha is given as cos of the angle. The angle is what? 30 degrees. So when you put cos 30 degrees on your calculator, you are going to get root 3 all over 2. Now since we have sin alpha here, let's also look for sin alpha. So we have our sin alpha is equal to sin what? Sin 30. And when you point sin 30 on your calculator, you are going to get what? 1 over 2. Now once you have this, we are just going to plug in into our xi. So we know that our xi is what? X cos alpha. Cos alpha is root 3 over 2. So we have root 3 over 2x plus our sin alpha is 1 over 2. So we have 1 over 2y. Now once we are done with xi, we move on to what? Eta. We move on to what? eta. And we know that eta is also giving us what? Minus x sine alpha plus y cos alpha. So we are just going to plug in this in place of sine alpha and then cos alpha. Very, very easy. So we have our eta is equal to sine alpha, we had 1 over 2, so we have minus 1 over 2x. And then cos alpha, we had 3 all over 2, and then we have what? Y. So right now we have our expression for xi, which is this, and then expression for what? Eta. Good. Now once you know this, what we are going to do is we find the partial derivative of the function xi with respect to what? X, and then with respect to what? Xi. So let's start with xi first. So we have xi x. It means we are going to differentiate xi with respect to x. So when we are differentiating xi with respect to x, any function of y becomes a constant. And whenever we differentiate a constant, we get 0. So it means that the whole of this will give us 0. We are left with this. When we differentiate root 3 over 2x with respect to x, we get what? Root 3 over 2, because this will give us 1. The derivative of x with respect to x is 1. 1 times root 3 over 2 will give us what? Root 3 over 2. So we have root 3 all over 2. Then we also take the partial derivative with respect to what? Y. So we are going to differentiate xi with respect to y. Any function of x becomes a constant. And whenever we differentiate a constant, we get 0. So this will give us 0. And then when we differentiate half y with respect to y, we get what? Half. Because when we differentiate y with respect to y, we get 1. 1 times half will give us what? Half. So we have half. Now we are done with xi. Let's move on to the eta. Eta. We are going to differentiate it with respect to what? X. So this is eta. We differentiate it with respect to x. Any function of y becomes a constant. So this will give us 0. And we'll be left with what? Minus 1 all over 2. Then we also take the partial derivative with respect to what? Y. We are differentiating eta with respect to y. So any function of x becomes a constant. This will give us 0. And we'll be left with what? Root 3 all over 2. Very, very, very interesting. Very, very interesting. So once we are done with this, the third step is that write an expression for ux and then what? Uy. So we said that our ux, our what? Ux, which is the partial derivative of the function u with respect to x, our ux is giving us what? U xi x plus u eta x. Very, very interesting. So let's start with us. Then once we are done with us, we move on to what? Ui. So we have xi x. So this is xi x. We also have eta x. So this is eta x. We are just going to plug in into this equation to give us the expression for what? Ux. So xi x, we have root 3 all over 2. And then we have u xi plus eta x. We have minus 1 over 2. And then we have what? U eta. Now we move on to the expression for what? Uy. Uy. It means we have to differentiate the function u with respect to what? Y. Going through what? Xi. We have to pass through xi before we get to y. So that one is also giving us what? U xi y plus u eta y. In our previous lesson, we discussed about this, how we came about this. So if you don't know where it came from, you can just go back and then watch the previous video on that. So once we have this, we have our xi y, where is that? This is xi y, and this is eta y. We are just going to plug in this into this. So we have xi y, that is half. So we have 1 over 2 u xi plus eta y, where is it? This is eta y. So we have with 3 over 2 and then we have what u eta. So this is uy, and this is what ux. So these are the 10 steps that we give, and then we move on to the fourth steps. Now the fourth step says that once you get the expression for ux and then uy, so once you get the expression for ux and then uy, what do you do again? Yes, what do? You go back and then substitute these two equations or these two expressions into the PDE question that was given, into the equation that was given. You substitute this expression into the equation that was given. So I always write the step 4 because it is very, very important, step 4. And these two equations is going to convert the PDE or reduce the PDE from a partial differential equation into an ordinary differential equation. Then we take it from there. So let's write our equation that was given is what? 3ux plus root 3 uy is equal to 1. So we have our constant 3. Ux, we had what? Ux was us. So this is us. We had root 3 all over 2 u there minus 1 over 2 u eta. Then we have plus root 3 uy. This is uy. So we are just going to plug in this 1 over 2 u there plus root 3 over 2 u eta is equal to 1. So once we are, let's expand the bracket. Let's expand the bracket. So when we expand the bracket, we are going to get 3 root 3 all over 2 u there. Then we have minus 3 over 2 u eta. 3 times minus half will give you this. Then move on to this. 3 times half u there will give you root 3 over 2 u there. Then we have plus root 3 times root 3 will give us 3 all over 2 u eta is equal to 1. So from here, you can see that some of the terms can cancel themselves. We can see that root 3 over 2 u eta, we have minus 3 over 2 u eta. So it means that these terms will cancel this term. So we are left with this, and then that is equal to 1. Let's continue from here. So we have root 3 over 2 plus root 3 over 2. This plus this will give us what? 4. We have 4 root 3 all over what? 2 u there is equal to what? 1. So you can see that the 2 cancel the 4. We have what? 2 root 3. This one is 3. Sorry. So we have 2 root 3 u there is equal to what? 1. Now let's divide both sides of the equation by 2 root 3, 2 root 3, so that we have 2 root 3 and then we have 2 root 3. So from here we can see that this will cancel this. We are left with what? U there is equal to what? 1 all over 2 root of 3. Now when you do the algebra, you are going to get U there is equal to what? Root 3 all over 6. Let's do it. When you rationalize the denominator, 2 root 3, when we rationalize the denominator, we are going to get 2 root 3 all over 2 root 3. So this is going to give us 2 root 3 all over this, giving us 4 multiplying what? 3. So we have 2 root 3 all over what? 12. This will cancel this. We have what? 6. So we have root 3 all over 6. So we can write it as that. Very, very easy and then interesting. So this form of the PDE is called the canonical form. The canonical form. So at this stage, we are going to integrate. We are going to do what? Integrate. So we have u Zaya is equal to 3 all over 6. Now you agree with me that when we have ux, we can write it using another notation. We can write it as what? Del u, del x. If that is the case, when you have u Zaya, we can write it as what? Del u, del Zaya. So we are going to write this in this notation form. So we have del u, del Zaya is equal to 3 all over 6. Very, very interesting. So once we have this, we separate the variables. So we are just going to multiply both of the equation by del Zaya and then multiply here by what? Del Zaya, so that this will cancel this. So we have our del u is equal to 3 all over 6 del Zaya. Very, very interesting. We've separated the variables into u and then Zaya. Therefore, we can integrate. So we are going to integrate both sides. Let's continue from the other side. We integrate u, we get what? U is equal to, when you integrate root 3 over 6 Zaya, we are going to get what? Root 3 over 6 Zaya. See, you realize that our variables that we are using now are what? Zaya and then eta. And since we are integrating with respect to Zaya, any function of what? Eta becomes what? A constant. So our constant becomes what? A function of what? Eta. So our general solution, which is in terms of Zaya and then eta, is given as u Zaya eta. Let me use this. Zaya and then eta is equal to root 3 over 6 Zaya plus a function of what? Eta. So this is the general solution, which is in terms of what? Zaya and then eta. But the question was given in terms of x and y, not Zaya and eta. We changed the variables from x and y to what? Zaya and then eta. So we have to return it back. That is the last step that I gave. Return the variables from Zaya eta to what? X and y. So how do we return our x and y back? If you remember at the beginning, we gave an expression for Zaya and then also an expression for what? Eta. So we are going to use that to return our original variables back. So we said that our Zaya is equal to what? Root 3 all over 2 x plus 1 over 2 y. And then our eta, we also said that our eta is equal to minus 1 over 2 x plus root 3 all over 2 y. So at this level, we can just simplify to make it smaller. So we can write this as root 3 all over 2 x plus 1 all over 2. Since the denominators are the same, 2 and 2, we can write this as this. And eta 2, we can write it as minus x plus root 3 y all over 2. So this means that wherever we see Zaya in this, we are going to replace it with that. And then wherever we see eta in this, we are going to replace it with what? With this. Very, very easy. So right now, our general solution, which is in terms of x and then y, is equal to 3 all over 6. And then we have our Zaya. Our Zaya is root of 3 all over what? Sorry. Root 3x plus y all over what? 2. And then we have plus a function of what? Eta. Our eta, we have minus x plus what? Root 3 y all over what? 2. So this then becomes what? Our general solution. This is our general solution. So this is our general solution. Very, very, very interesting. And then very easy. So we realize that we were given an auxiliary condition, an initial condition to find the particular solution. So you have to proceed to find the particular solution. So the initial condition that was given is what? U at x, comma 0 is equal to what? S squared. So this means that wherever we see x in the general solution, we plug in x. Wherever we see y in the general solution, we plug in 0. Wherever we see u in the general solution, we plug in s squared. So we have our u here. So we are going to have our s squared is equal to root 3 all over 6. And then we have our x is still s. So this is going to give us what? Root 3 x all over 2. This is going to give us 0. So we'll be left with this one. And then we have a function of our y is also equal to 0. So we are going to be left with minus x all over 2. Very, very easy and then simple. Let's make f at minus x over 2 the subject. So we are going to have our f at minus x over 2 is equal to s squared minus what this. Very, very easy and then simple. So at this point, what we are going to do is we are to just simplify this more. Let's simplify this more and see what we are going to get. So we have our f at minus x all over 2 is equal to s squared. This is going to give us 3x all over what? 12. And when you do your cancellation, you are going to have x all over what? 4. So let's make it x over 4. X all over 4. Very, very easy and then simple. So let's continue from this side. So from here, we are going to let any variable at all. So let's say the variable p to represent what is in the function. So we have minus x all over what? 2. Then from here, we make x the subject. So when we make x the subject, we are going to get our x is equal to what? Minus 2p. So we are going to substitute this and that into this equation. So we have our f at p is equal to what? We are saying that our x is what? Minus 2p. So we are going to get minus 2p and all of this is what? Squared because of this. Then we have minus, our x is what? Our x is minus 2p. So we have minus 2p all over what? 4. So we have our f at p is equal, this is going to give us 4p squared. And this is also going to give us 2p all over what? 4. So when we do the cancellation, we're going to get p over 2. So we have our f at p is equal to 4p squared plus what? P all over what? 2. Very, very easy. So at this point, what we are going to do is that we are going to go back to the general solution and then we search for f, the function. So this is f. So what is in the function in the general solution? We are going to write it to replace p. So it means that we are going to write the whole of this to replace what? P. So we have our f at minus x plus root 3y all over 2 is equal to 4. Our p is this one, so we can write it as root 3y minus x all over 2, and all of this is what? Squared. Then we have plus p root 3y minus x all over what? 2. So it means that once we have this, we still go back to the general solution again, and then we substitute this in place of what? F. So wherever we see this in the general solution, we are going to plug the whole of that. I believe you are following. Very, very easy. So we have a particular solution to be u at x y is equal to, we have this root at 3/6. Then we have then wherever we see the whole of this, we are going to replace it with that. So we are going to have 4 root of 3y minus x all squared. Then this is giving us what? 4. Then we have plus root 3 all over 2. Very, very easy and then simple. So for me, we can also see that this will cancel this, right? So our particular solution will be giving us u at x, y is equal to what? Root 3 all over 6 all over 2 plus minus x all squared plus root 3y minus x all over 2. Very, very easy and then simple. So this is our particular solution. Let's look at another example. So this is going to be our last example under the change of variables with constant coefficient. So let's go through it. So what we are going to do is to identify our a and then our b, form the equation given, and we know that our a is the coefficient of us and then our b is the coefficient of what? Uy. So we have what? Root 3 and then our b is the coefficient of uy, that is 1. So once we have this, we find our angle, which is what? Alpha. So we know that alpha, which is the angle, is given as what? Tan inverse of b all over a. So we have our alpha is equal to tan inverse of our b is what? 1. And then our a is what? Root of 3. So when you point it to your calculator, our alpha is equal to what? 30 degrees. Very, very easy and then simple. Now once we have this, we find the expression for xi and then the expression for eta. So our xi is given as what? X cos alpha plus y sin alpha. So from here we can find our cos alpha and then what? Our sin alpha. So cos alpha is what? 30. So we have 30 degrees is going to give us what? Root 3 all over 2 and then sin 30 will also give us what? 1 all over 2. So once we have this, we are just going to plug it into this to find what? Xi. So we know that xi is equal to cos alpha, we had root 3 all over 2, and then we have x, and then we have plus sin alpha, we had 1 over 2, so we have y all over 2. So with this, we can simplify and write xi as what? Root 3x plus y all over 2. Very, very easy. Now let's move on to the expression for what? Eta. So we have eta. So with the eta, it is also given as what? Minus x sin alpha plus y cos what? Alpha. So from here, our sin alpha is what? 1 over 2. So we have minus x over 2 plus cos alpha, we had root 3 all over what? 2 and then multiplying what? Y. So with these two, we can simplify it and write it as minus x plus root 3y all over what? 2. Very, very easy and then simple. So once we find the expression for xi and eta, what do you do again? We find the partial derivative of xi with respect to x and then with respect to y. And then we find the same thing for xi. We find the same thing for eta as well. So we find our xi x, the partial derivative of this function with respect to what? X. Now when we differentiate the whole of this function with respect to x, any function of y becomes a constant. So this will give us 0. And then when we differentiate this with respect to x, we get what? Root 3 over 2. So we have root 3 all over 2. Then we find xi y. We differentiate the same function with respect to y. Any function of x becomes a constant. So this will give us 0. And then we have what? 1 over 2. Then move on to eta x. We differentiate this function with respect to x. Any function of y becomes a constant. So this will give us 0. And then this is giving us what? Minus half. And then we have eta y. So this will give us 0. We are left with root 3 all over what? 2. So once we are done with this, we move on to the test that we say that find the expression for ux and then what? Uy. We write an expression for ux and then uy. So we know that our ux is given as what? U xi x plus u eta what? X. So let's plug in xi x and then eta x. Since we have xi x and then eta x, we are just going to plug in. So we have our ux is equal to xi x, we have root 3 all over 2, and then we have u xi. Then we have plus eta x. So this is eta x. We have minus 1 over 2, and then we have u eta. Now once we are done, we move on to the expression for uy. So the expression for uy, we have u xi y plus u eta y. Since we have xi y, which is this, and then eta y, which is this, we are just going to plug this and that into this equation to give us the expression for what? Uy. So xi y, we have half. So half u xi plus eta y, we have 3 over 2. And then we have what? U eta. So once we are done with this, we move on to the fourth step. So the fourth step, I always write it very, very significant. So with the fourth step, we say that substitute ux and then uy into the equation that was given. So we are going to substitute this and then that into the equation that was given. So the equation that was given is what? Root 3 ux. So we have root 3 ux plus what? Uy is equal to 0. So wherever we see ux, we plug in this, and then wherever we see uy, we plug in what? This. So we have 3 root of 3 multiplying ux. So this is ux. Then we have our plus. So we have uy. So this is uy. That is what? 1 over 2 u xi plus root 3 all over 2 u eta is equal to what? 0. So let's expand this bracket. So this is going to give us what? 3 over 2 u xi minus root 3 over 2 u eta. When we expand the bracket, this time this will give us that. And then we have 1 over 2 u xi plus root 3 over 2 u eta is equal to 0. So from here, you can see that some of the terms can cancel. So we can see that positive root 3 over 2u eta will cancel negative with 3 over 2u eta. So with this and that will run away. They will move. So we are left with this and then that. Good. So let's continue from here. Then we have plus 1 over 2 u Zaya is equal to what? 0. So we have the alike terms are u Zaya, u Zaya. We can add them. So this is going to give us 4 u Zaya all over 2 is equal to what? 0. Because this will give us 4 and the u Zaya. The denominators are the same, we can pick one. So with this 2 cancel 4, we have 2 u Zaya is equal to what? 0. So what do you do? Let's divide both sides by 2 to get away with what? The 2 here. So dividing both sides by 2 is giving us what? U Zaya is equal to what? 0. So we know that U Zaya can be written as what? Del U del Zaya. So we are going to write this as del U del Zaya is equal to what? 0. Now let's separate the variables into U and then what? Zaya. So we can write this as del U is equal to 0 del Zaya. Now once we have you can see that we've separated into U and then what? Zaya. We can what? Integrate. We can integrate both sides. Now when we integrate the U, we are going to get what? U. And then when we integrate 0 the Zaya, we are going to get a function of what? Eta. Very, very easy and then simple. So we know that our general solution, which is in terms of what? Zaya and then what? Eta is equal to a function of what? Eta. But remember that the question was given in terms of x and then y, and then we change the variable from x and y to what? Zaya and then eta. So we have to return our variables back, our original variable, that is x and then y back. So we are going to change Zaya and eta to what? X and then y. Let's continue from here. So how do we change Zaya and eta to what? X and y? Remember that we give an expression for Zaya and then an expression for eta. So we said that Zaya is given as this and the eta is also given as that. So it means that wherever we see Zaya and then eta in the general solution, we replace them with this. Wherever we see eta, we plug in this in the general solution. So we have our u at x, y is equal to a function of eta. Eta is what given as this. So we have root 3 y minus what? X all over what? 2. So this becomes our general solution. This is what? Our general solution. So we realize that we were given an auxiliary condition, so we have to proceed to find the particular solution. So the initial condition that was given is what? So this is the auxiliary condition that was given. So with this initial condition given, it means that wherever we see x in the general solution, we plug in 0. Wherever we see y in the general solution, we plug in y, which is this. And then wherever we see u in the general solution, we plug in the whole of this. 4e x to the negative 2y. So we are going to plug this in the general solution to help us find the particular solution to the equation given. So our u is what? 4e x to the negative 2y is equal to our function of root of 3y. Our y is still y, so we are still going to have root of 3y all over 2. And then our x is 0. So when we plug in 0 here, that part will go away. We'll be left with root of 3y all over 2. So what we are going to do is that we are going to let any variable at all to represent what is in the function, any variable at all to represent what is in the function. So let the variable p to represent what is in the function, which is root 3 y all over 2. Then from here we make y the subject. So you can say that y also is equal to what? 2p all over what? Root of what? 3. So wherever we see root 3y over 2, we plug in p. And then wherever we see y, we plug in 2p over what? 2y. So let's plug in this in this equation. So we are going to have f at p, that is f at this, is equal to 4e exponent negative 2. Our y is what? Our y is giving us 2p all over what? Root of what? 3. So from when you do the algebra, we are going to get negative 4p all over root of 3. So we have f at p is equal to 4e exponent negative 4p all over root of 3. So what we are going to do here is that we are going to go back to the general solution and then we search for the function f. So what is in the function? We are going to use it to represent p. So it means wherever we see p, we are going to write this there. So we are going to have f at, we are saying that this is our p. So we have root 3 y minus x all over 2 is equal to 4 e exponent negative 4. Our p is what? Let's add the root 3. Our p is root 3y minus x all over 2. So from here we can do some small algebra here. So let's continue from this side. So we have 4e. So let's write the 4 and then we have the e. Now with the exponent, let's write and then let's simplify this more. We have minus 4 all over root 3 and then multiplying with 3y minus x all over what? 2. Now when we expand the bracket, we are going to get minus 4 over root 3 multiplying what? Root 3y all over 2. And this will give us negative, it will give us positive 4x all over root 3 multiplying 2. So from here we can see that root 3, this root 3 will cancel this root 3, these two will cancel negative 2. So at the end we have negative 2y, and then from here we can see that these two will cancel 4, we have 2. Then we have plus 2x all over what? Root 3. Good. So at this point we can decide to find the LCM and then simplify further. So our LCM is going to be 3. 1 into 3 we have 1 into 3 we have root 3 times this, we have negative 2y multiplying what? Root 3. Then we have plus what? 2x. So we can write this as 2x minus 2 root 3 y all over what? Root 3. From here also we can factorize 2 out. So we have 2 all over root 3. Then we have what? X root 3 and then y. So it means that the whole of the exponent, which is this one, is going to give us this. So we are going to write power 2 all over root 3. Then we are multiplying x minus what? Root 3 and then y. Very, very easy and then simple. So now that we have simplified this means that wherever we see f at root 3y minus x all over 2, we are going to plug in this. And that is the whole of that. So our particular solution is going to be u at x, comma y is equal to what? This. And this is the same as that. And this is equal to that. This is also the same as that. So we have 4 g exponent 2 all over root 3. We have x minus root 3. Why? Very, very easy and then simple. So this becomes our particular solution. So this brings us to the end of today's lesson. See you tomorrow. If you really enjoyed today's lesson, make sure you subscribe to the channel for more exciting episodes to come. Bye bye.